like, subscribe, and comment. We really appreciate knowing what's resonating with you, and don't be afraid to make suggestions for future episodes. Hey, so no matter whether you're talking about ChatGPT, Gemini, Copilot, or name the AI platform, they all have something in common, and that is they use language models under the hood. So this is Tim.
And this is Tim. And we just watched a video on how LLMs work. And to be honest, it raised as many questions as it did provide answers.
So follow along. Maybe you'll learn something too. Feel free to look out when we say anything that is incorrect, and let us know in the comments.
All
Large
right.
language model for the curious beginner. Let's
I
go.
am LLM curious myself. Let's roll.
Imagine you happen across a short movie script that describes a scene between a person and their AI assistant. The script has what the person asks the AI, but the AI's response has been torn off. Suppose you also have this powerful magical machine that can take any text and provide a sensible prediction of what word comes next. You could then finish the script by feeding in what you have to the machine, seeing what it would predict to start the AI's answer, and then repeating this over and over with a growing script completing the dialogue. When you interact with a chatbot, this is exactly what's happening.
One thing that's just blowing my mind is, how do you even start the first word? Like it said there, the AI assistant, it came up with A. How did where do you even, to me, that seems like the hardest part is like, where do you start? Because it never shows it going back and fixing a word after. It's always just moving forward. So what happens if it started with if instead of A?
My guess, it seems like those are probably the same mechanics. It seems like the variability of words that we use to start sentences is pretty limited.
All right.
If, a, when.
And it must be in relation to the question of what it thinks it's almost as if, because this is implying it's literally decided word by word is in a vacuum, but it cannot be. It's got to have some sense of the overall structure and sentence.
The context. Yeah. Let's take a look and see. Yeah, I thought it was more than just word by word.
A large language model is a sophisticated mathematical function that predicts what word comes next for any piece of text. Instead of predicting one word with certainty, though, what it does is assign a probability to all possible next words. To build a chatbot, what you do is lay out some text that describes an interaction between a user and a hypothetical AI assistant. You add on whatever the user types in as the first part of that interaction, and then you have the model repeatedly predict the next word that such a hypothetical AI assistant would say in response, and that's what's presented to the user. In doing this, the output tends to look a lot more natural if you allow it to select less likely words along the way at random. So what this means is
So what he just said was like, hey, we're allowing this variability because it seems more natural when we do that. Okay, cool, got it. But when we're using not about GPT or anything in a technical field, we don't want that variability. So is there a way in the LLMs just disable this variability, give me predictability every time rather than allowing this variability? Or would it not work?
I wonder about that as well. Yeah, if you want to, and maybe this is a setting that they can tune to help prevent hallucinations. It's just saying stuff going, oh yeah, this is totally.
If you're telling me how to write some not about code, I want you to give me the same results every single time. I don't want you to come up with different ways to do it every time. I would rather have predictability. So I'm wondering, is there a way to just disable? Yeah.
But this speaks, I think, to the amount of variability. The model has to account for the variability of the initial question by the user. So there has to be something built into the model that can account for that variability. And as soon as you do that, you're going to get less deterministic results.
So it would seem.
So I said, I'm sure that's true. Well,
must be.
Maybe not.
Even though the model itself is deterministic, a given prompt typically gives a different answer each time it's run. Models learn how to make these predictions by processing an enormous amount of text, typically pulled from the internet. For a standard human to read the amount of text that was used to train GPT-3, for example, if they read nonstop 24/7, It would take over 2,600 years. Larger models since then train
Okay,
on
I'm just going to
much.
stop right there. 2,600 years. That's how long it took me to get through the novel Dune. Just a marker there for people. All right.
Much more.
Oh,
You can
same
think of
amount of time.
training a little bit like tuning the dials on a big machine. The way that a language model behaves is entirely determined by these many different continuous values, usually called parameters or weights. Changing
I
those
find watching
parameters
that
will
video
change the
very,
probabilities that the model
it's very
gives for the
enjoyable.
next word on a given input. What
It's
puts
watching
the
fire.
large in large language model is how they can have hundreds of billions of these parameters. No human ever deliberately sets those parameters. Instead, they begin at random, meaning the model just outputs gibberish, but they're repeatedly refined based on many example pieces of text. One of these training examples could be just a handful of words, or it could be thousands, but in either case, the way this works is to pass in all but the last word from that example into the model and compare the prediction that it makes with the true last word from the example.
Hey,
An
Foster.
algorithm called backpropagation is.
So I think what I'm understanding now as I see this is that LLMs are trained, and that training is essentially a one-time event. And it would seem, at least with GPT-3, what he referenced there, that it's not continuing to learn, right? Like it's trained and that's it. Is
Yeah,
that accurate?
that's my understanding as well, that the model is the model once it's trained. And then you can do it's not training, but the model can learn about you through your frequent interactions with it, is my
Right.
understanding. But that's not really being trained. That's just more the model picking up on context. There is a nuance there that I cannot fully explain, but it's my understanding that is the case. The model is the model, and then the more you use it, uh, it's possible that the model can get to know you a bit better.
I wonder if the next iteration of this concept is that models that continuously learn rather than get trained once and then that's it. I don't know.
Well, there's also this. I'm curious how that fits into the retrieval augmented generation, which is how you can give a model like a PDF and tell it to explain it to you, or frame its answer with the context of the PDF that you just gave. Retrieval augmented generation. I wonder how that fits into this.
Hmm.
Used to tweak all of the parameters in such a way that it makes the model a little more likely to choose the true last word and a little less likely to choose all the others. When you do this for many, many trillions of examples, not only does the model start to give more accurate predictions on the training data, but it also
Trillions.
starts to
I
make
don't know.
more reasonable predictions
Something
on text that it's never seen before. Given the huge number of parameters and the enormous amount of training data, the scale of computation involved in training a large language model is mind-boggling. To illustrate, imagine that you could perform 1 billion additions and multiplications every single second. How long do you think that it would take for you to do all of the operations involved in training the largest language models? Do you think it would take a year? Maybe something like 10,000 years? The answer is actually much more than that. It's well over 100 million years. This is only part of the story, though. This whole process is.
I'm going to pause this here. 100 million years worth of training goes into these
at one
LLMs
at 1 billion transactions per second.
per second.
So obviously that means it didn't take 100 million years. We assume this isn't technology from the future. So that means they threw a whole lot of horsepower and processing at this thing.
Yeah,
Like,
I think this
whoa,
goes towards explaining the high energy and power strain
consumption.
this is putting on the hyperscalers
Right,
and actually everyone who's making one of these.
to run these
Called pre-training. The
GPU
goal of
farms.
auto-completing a
Yeah.
random passage of text from the internet is very different from the goal of being a good AI assistant. To address this, chatbots undergo another type of training, just as important,
More training.
called reinforcement learning with human feedback. Workers flag unhelpful or problematic
So
predictions,
I
and their
imagine
corrections further change.
I imagine this to be like you're in the boot camp and they have a sergeant just yelling at the chatbot like jumps. Give me 10.
I love that.
matched the model's parameters, making them more likely to give predictions that users prefer. Looking back at the pre-training though, this staggering amount of computation is only made possible by using special computer chips that are optimized for running many operations in parallel, known as GPUs. However, not all language models can be easily parallelized. Prior to 2017, most language models would process text one word at a time. But then, a team of researchers at Google introduced a new model known as the transformer. Transformers don't read text from the start to the finish. They soak it all in at once, in parallel. The very first step inside a transformer, and most other language models for that matter, is to associate each word with a long list of numbers. The reason for this is that the training process only works with continuous values, so you have to somehow encode language using numbers, and each of these lists.
Okay, yeah, we should definitely talk about this. So this is the T in GPT. This is the transformer in GPT.
So for 1 second, I just would like to know, why doesn't this transformer have a cool theme song and, more than meets the eye? Like I'm a little bit disappointed, to be honest.
I know. I don't understand that about tech either. It's so weird. But this is fascinating what we're seeing here. So if I'm understanding it right, it's taking a word and encoding it, describing that word using these numerical values. Oof. Okay. That alone, I think, is like a PhD.
Agreed. And this in a former life, I worked at a hyperscaler where we provided object storage as opposed to block storage. So object storage is where you send a file to an API and it just stores that for you in some magical way. And it's done via this hash encoding method where you take the file and hash it with other files, and you end up just storing a bunch of numbers that somehow can be magically turned back into the file again. And it reminds me a lot of the similar concept of the way that you are using math to store information. It still blows my mind that it's even possible, but yeah.
Yeah, there's a lot to unpack here that I am not capable of unpacking.
Understanding.
Numbers may somehow encode the meaning of the corresponding word. What makes transformers unique is their reliance on a special operation known as attention. This operation gives all of these lists of numbers a chance to talk to one another and refine the meanings that they encode based on the context around, all done in parallel. For example...
Okay, backing up a second here to that visual. It's changing the values of these numbers that describe the word based on the context, the other words around a given word. There's my second PhD. Okay.
So it is going backwards to fix it. It isn't like we initially saw in the video where it's one word at a time moving forward. It is actually then changing things in the past. This makes more sense now.
Yeah, and this definitely seems like something Google would have invented. All right.
All done in parallel. For example, the numbers encoding the word bank might be changed based on the context surrounding it to somehow encode the more specific notion of a riverbank. Transformers typically also include a second type of operation known as a feed-forward neural network, and this gives the model extra capacity to store more patterns about language learned during training. All of this data repeatedly flows through...
That seems really important, and we just kind of like breezed through it in one sentence.
Glossed over this magic bit that they're like,
wow.
And it's really cool, but yeah, moving on. It must be really
neat
difficult to explain.
Trust us. Yeah. Fair. This is an intro video, but yeah.
Many different iterations of these two fundamental operations. And as it does so, the hope is that each list of numbers is enriched to encode whatever information might be needed to make an accurate prediction of what word follows in the passage. At the end, one final function is performed on the last vector in this sequence, which now has had a chance to be influenced by all the other context from the input text, as well as everything the model learned during training, to produce a prediction of the next word. Again, the model's prediction looks like a probability for every possible next word. Although researchers design the framework for how each of these steps work, it's important to understand that the specific behavior is an emergent phenomenon based on how those hundreds of billions of parameters are tuned during training. This makes it incredibly challenging to determine why the model makes the exact predictions that it does. What you can see is that when you use large language model predictions to autocomplete a prompt, the words that it generates are uncannily fluent, fascinating, and even useful.
Sometimes. This reminds me when I was in grad school, one of the professors was telling us that when he was an undergraduate or before he got his degree in computer science, that he thought computers were magic and they just did magical things. And then he went and got his degree in computer science and bachelor's degree in computer science, and he learned that computers are not magic. They do what you tell them to do. And then he went on to get his PhD in computer science, and he learned that computers really are magic. We don't exactly know how they work, which I think is what he just said. I think he just said, we don't really know how this works.
Yeah, this is fascinating. This is absolutely fascinating. Yeah, 3 things there I got from that. There's the training phase, then there's the human feedback phase to give it a bit more tuning as to what humans want. Then there's this context management that allows it to kind of understand not just a word, but the context around the word to make the next word better. And they're doing that with math.
Mathing the math.
Mathing the math. Wow.
So this has been Tim and Tim reacting to large language models. We learned a few things. We made some comments. We probably made some stuff up. If we said something wrong, please let us know in the comments. If you like what we said, please react. Let us know what your thoughts are. How are large language models and AI impacting your life and your work, no matter what it might be, whether it's using Nautical GPT or some more commonly based open source model.
That's right. Going forward, let's all stay open-minded and stay curious.